Hello and welcome to this video on the Imperial lasgun, or as Space Marine and Orc players would call it, the Imperial flashlight. The lasgun is at its simplest a very powerful laser, a portable, powerful laser. The question is just how powerful? The answer to that question can really only be answered by seeing how much power you can supply it with, for how long and how far. Since the lasgun is considered a rechargeable and reloadable weapon, the battery pack that powers it must have both a reasonably set capacity but also a regulated discharge rate. That is the only way to ensure it fires a relatively set number of shots per power pack and doesn't explode the weapon in your face or fail to hold a charge and therefore leave you with a very fancy club and not a laser. That does mean we can work back from the power shot to the power of a lasgun power pack, or at least in theory. As you'll see, the process is complicated by some of the Imperium's inefficiencies. The lore gives us a few fairly solid ideas as to what we need to estimate the lasgun power pack capacity. We know there are 4 standard sizes of lasgun power pack, essentially a pistol size, a small carbine size, a rifle size, and a large rifle size. We can start looking at the biggest size and working our way down in capacity. Before that, at least before we get to that stage, we can start with the beginning and get the outline of lasgun power and use some simple comparisons, both to known weapons, power and effect, and also those that are in lore that we have a bit more solid information on. First, we start by observing the lasgun. It's a laser and we can estimate the range of the lasgun. That's a simple means of estimating the power of the laser as it loses power over distance. The power loss is a result of the way lasers diffract as they pass through the air. Essentially, the beam gets less and less narrow. It means that with distance we can calculate power with some assumptions. A 5 mW laser is a burn risk at 11 meters. That means you need 500 mW of power for the laser beam. We also know that at close to point blank range, a Hellgun variant on the lasgun can penetrate a Space Marine's armor, more than likely in the weakest points, so the visor, the joints and so on, but we know you can put a hole in one of them. Given that a Space Marine is expected to take on anything the universe has, and the universe is full of all sorts of things, whether it's creatures with teeth where you don't want them, spiky things, angry people who want to torment you to death, pointy-eared space elves, and who knows what else, beyond the space communists. Yeah, the fact it can put a hole in them, or at least put them down, means it has to have a lot of power. Once you start putting these sorts of facts together, we can say the Hellgun can put out a measurable amount of power, and we could theoretically figure that out. For example, if you compare it to the bolter, a bolter round can do roughly the same sort of work. Basically, it can put down a Space Marine. Again, in theory, it requires it hitting in a weak space, or place, but it can do so. We know the bolter round has around 20 kilojoules of energy and a range of between 10 and 30 kilojoules. In terms of its explosive power, it's somewhere between 210 and 360 kilojoules. So let's settle on the middle ground and say 255. Taking the average of 255 kilojoules for now, we can convert this to watts. 1 kilojoule for 1 second is 1 watt. As the lasgun travels at the speed of light, we can make a reasonable assumption that most shots, and more so for these at point-blank killing range, will be at or less than a second. And that means we can show that it is at least 255 watts each time. However, it is very likely that the actual time is much less. If we assume the target is a very angry Space Marine 1 meter away, and the time the light shot takes to travel to them is roughly 3.35 to the negative 9th power, or essentially 0.90-33556 of a second. It's a tiny fraction of a second, which is probably not as realistic, but let's work on that basis for now. Mostly because it gives us first of all, a giant number, and b, it's probably more accurate, at least from a pure physics point of view. What we know is that you're going to hit that very angry Space Marine with 59,959,227,725.15 watts per shot. Basically just shy of 60 billion watts per shot. And you would hope you hit them with that much, because if you don't put them down with it at the point-blank range, you won't get a second chance. Then again, most Hellgun users are from the deathcore of Krieg, and they probably welcome not having a second chance. The Hellgun in this case, though, does not rely on the standard Imperial Guard laspack. Instead, they use a large backpack-sized unit. Despite this, we know it can produce 200 shots before being completely discharged. Or at least that's what some of them claim. Now, there's one of the points we need to make now before we go any further. there is a lot of discrepancy in the law as to just how many shots can be made by each version of the lasgun, how many can be used, and so on and so forth. It's typically understood that the Corps Krieg Grenadiers who use these lasguns, the Hellgun particularly, generally don't have that many shots, and so they're supposed to be supported by chimeras carrying more backpacks they can use to charge their weapons. But for now, let's assume that we're talking about a more regular gun after we finish this section. Just understand that there's a lot of issues around the number of shots that can be made, and not just because of the Hellgun itself, but different variations on the lasgun can fire different numbers. Anywhere it's said between 10 shots and up to 200 shots, and sometimes more again. In fact, in law, this is somewhat more confusing for us, as it's claimed the Hellgun battery pack has a power capacity of 28 megathouls, and it's generally been accepted that this is a deliberate misspelling of megajoule. If it is the equivalent of a megajoule, then the first calculation of roughly 255 kilojoules is probably not very wrong. 20 megajoules is equivalent to 28,000 kilojoules. That's about 109 shots from a Hellgun. Assuming some degree of, let's say, space magic nonsense regarding better lenses, shorter firing times, and so on, you might be able to stretch that out to the full 200 the Fluff and Law state. Understand though, that applies to the lasgun, not necessarily the Hellgun, and therein lies a big problem. But the reason we think you might be able to tweak the numbers is the lasgun does not rely on purely kinetic power. In fact, it can't rely on kinetic power, at least not in any significant way since it's a laser. It can theoretically fire photons, and photons can in theory carry some modicum of physical force, but it's so tiny due to the tiny mass of the photon that it really doesn't matter. Instead, it almost entirely relies solely on energy transfer, and this would be mostly in the form of heat. That is rather more difficult to calculate without knowing the exact heat density of ceramite, which is the armor that makes up Space Marines amongst others. This means we now need to move on to our next option, which is stupidly more mathematic, or at least more mathematical in the sense of we're having to do a lot more questionable work to get a calculation. We move on to relying and looking at primarily on the what's supposed to be a standard power pack. That is something that is at least theoretically comparable to a grenade, and that's because veteran guardsmen use the power pack as a makeshift grenade. When this happens, it's meant to behave like a regular frag grenade, but without the same fragmentation effect. This is somewhat useful as we can somewhat compare it to our real-world grenades. A frag grenade blast has a radius and can kill, well, in theory, unpowered people at roughly 3 to 5 meters. To keep it simple, let's just say 5 meters, which is consistent with current existing grenades like the M67. We know the M67 weighs approximately 400 grams, or about 14 ounces in freedom units. The explosive filler can send this out with a detonation velocity of 6,900 meters a second. That equates to a power of roughly 9,522 joules, or basically the same in watts. Dividing this power by the standard 150 shots for a lasgun, we get 63,480 watts a shot for each las pack. Now, if you were to theoretically triple the power, so that is overcharge the shot, you would obviously get closer to 190,000 watts, but you'd only get 50 shots, and inversely, if you were to decrease the power, you would get more. But this is one problem we have. It's assuming that we're using an average shot here, but the lasgun is meant to be able to put a fist-sized hole in the torso of a person. This means our figure seems rather low. In AWS, that's Arctic Warfare Systems, a sniper rifle fires a standard NATO 7.62 by 51mm round. That needs 3,447,380 joules, or approximately 3.5 million watts, to do the same. There is a big gap to this though. The AWS is firing a solid projectile, and the references to large-scale injuries may be from higher power weapons such as the Hellgun, so it's not clear, from the lore and fluff at least, whether or not we can compare the AWS, which is firing a sniper rifle round, which can do the same job, that is put a large hole in somebody's chest, with a essentially giant laser. It does also bring us back to the earlier mentioned point. The range of shots from a standard las pack will vary somewhat between las rifle design or las gun design and the nature of the pack being used, with the ranges between 30 and 200 shots being quite reasonable. That means we have between 5 times the value we've given and slightly less than that value. So we have to raise concerns whether or not the numbers we've given are even remotely accurate. As far as the lore goes, the Lucius pattern lasgun uses a standard power pack of 21 megajoules, and if we assume the same convention regarding the megajoule to megathil convention misspelling, we know that there are 21 megajoules of power in it. If we assume the previously mentioned values are for the size or most common size of power pack used by the Imperial Guard, we can now go to the size 4. It tells us immediately that size 3 is 21 megajoules in capacity, but the size 4 is meant to be used by the heavy infantry version, that is, your assault, grenadier, and similar divisions. This means we would expect to see stormtroopers using this weapon, and it's also distinct from the Hellgun. Being intended for heavy weapons, it should be larger in capacity. The size 4 power pack is supposed to be able to provide twice as much power for the lasgun. This is commonly seen in the form of a drum power pack compared to the usual square or box shape. It is possible that the banana shape or similar las packs are also this classification, although more likely to be used as a Type 3. The Type 4 is likely to be the 28 megajoule or megathul power pack we mentioned at the start of the video. So we now know that the standard is 21 megajoules, the size 4 is 33% larger at 28 megajoules, and now we have the size 1. The size 1 is for las pistols, and unlike the other power packs, this has far less information available. We know its use and or application, but less about how effective it is. Being primarily an officer-issued pistol in the Warhammer universe, it's unlikely to be anything more than a symbolic weapon, and have very little practical use. And to be clear, it will still leave a nice scorch mark and probably put down a human or communist blueberry with a decent hit, but against an orc, a superhuman space marine or necron, it's probably not going to do much. Then again, most officers are a form of commissars, and their biggest issue is not necessarily the Xenos, instead it's guardsmen not doing their job, or showing cowardice in the face of the enemy, or showing signs of mutation, heresy, corruption, becoming a furry, the list goes on. The size 3 is effectively the same as the size 2, but it does have some greater capacity since it's used by specialized drop troopers and similar units expected to be that resupply or support for an extended period of time. A standard capacity for this power pack, based on the Minerva Aegis Las carbine, is 80 shots, which is half of what we would expect of the 150. That means in theory, each shot is going to be about twice as powerful as what we've calculated for, although conversely it could also be nearly 3 times as or less powerful. 3 times more shots, but a third of the power. The last thing we need to mention are the Hotshot packs. Now, these are only expected to lead to about 20 shots per magazine as such. Battery pack, las pack. What is the correct term? Hotshot packs are considered specifically for Hellguns. This is a broader classification for weapons that use a higher power pack and draw more energy for a more powerful shot as standard. Now, this does place greater stress on the weapon, but it can also cause the enemy to be injured or killed in just one shot, rather than a series of volleys from an entire squad or guardsman. The reason that we point these out are that significantly fewer shots are available from these Hotshot packs. So in theory, if you were to condense the essentially equivalent power needed for 150 shots into 20, this is what you're going to get. That does mean, at least in theory, that the lasgun power pack needs to be a slightly different connection to the lasgun, or hellgun in this case, in order to transfer that power to the lasgun or the hellgun much more efficiently. If we take for granted that the Hotshot power pack is a standard power pack, but with the power of each shot increased at the expense of number of available shots, then it would still largely fit with the existing information. The only difference is that we expect it, due to the greater number of shots needed, to be the larger number 4 power pack, as not only does it have a greater capacity, it means those 20 shots each get an equal share of the 28 megajoules. That does mean you're going to get somewhere in the ballpark of 1.7 megajoules per shot. There is one final element to all of this that needs saying, although technically it doesn't affect the charge held by each power pack. It does relate to how the lasgun can use it, and so that the lasgun can be set to a higher or lower level of power. Strictly speaking, this doesn't alter how much power the lasgun as a power pack holds, but given everything we've mentioned so far, it is a notable confounding variable in how we estimated the charge of the pack. We've already explained how we assumed that 150 shots is a standard power pack discharge rate. That would mean the lower setting would increase the number significantly. It would also mean that the high discharge rate is explained by an increase in the weapon power setting. Essentially, the lower you set each shot to, the more shots you will get. Therefore, as you decrease the number of shots, each individual shot becomes more powerful. From a math point of view, it makes more sense as the numbers fit better. From a lore and fluff point of view, it is a glaring weakness in this whole video. Of course, glaring weaknesses is a relative term. Remember that the power pack or lasguns are created in the billions, and they need to be created in the billions because they are issued generously and provide a highly effective rechargeable source of ammunition for a ubiquitous weapons system. In theory, a power pack can largely be swapped between any soldier, easily refurbished or otherwise made useful, with almost no effort. By contrast, if you tried doing that with modern weapons today, you'd need to account for dozens of ammunition types, powder charges, calibers, casings, and more. In exchange for the ubiquity, you are however walking around, or running around in the case of the Imperial Guard, with the equivalent of several grenades in your pocket. Grenades that when damaged become easily triggered with too much rough treatment. The kind of rough treatment that would occur when in melee or being on the receiving end of an orc sign of friendship. Or in the case of a Chaos Space Marine, just them trying to have fun. So yes, the current power rating for a lasgun is arguably a lot, and we'll give the final numbers here for you, assuming each of them is a rough relative measure of the others. So yeah, it's not fun to be running around with that kind of weaponry, particularly given how dangerous they can be. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. And please do post any comments, questions, or suggestions you have below.